Let's understand the probability distribution. As the definition say that it is a mathematical function that gives the possibility, note this point, possibility and probability of occurrence of different possible outcomes for an experiment. If we do any random experiment and whatever the possible values we get in the form of probability or a percentage, like how many percentage we get, what is the probability of getting in an event, there are like 1 2 3 4 5. So what is the probability of getting one, what is the possibility of getting one value? So this type of the distribution of this value in the form of probability or possibility is called as a probability distribution. Let's understand. There are two types of the probability distribution. When the random variable is in discrete in nature, that is called as a discrete probability distribution. If the random variable is in continuous in nature, that is called as a continuous probability distribution. So let's understand the discrete probability distribution. So when the set of the possible outcome in discrete, as we had discussed just earlier, whenever the random variable have a data in discrete in nature, that is called as a discrete probability distribution. Let's understand by one example here. How many heads when we toss the 3 coins? We have 3 coins here. It could have head or tail, head or tail, or head or tail. And what the random variable should have? Random variable should have the number of heads is the random variable. We need only heads. This and this in our random variable. So what would be the sample space? Sample space would be there is no any head, one head, getting one only head, getting two only head, or getting all 3 head. So this is your sample space. But total output values in this particular event, all 3 heads, 2 heads, 1 tail. So this type of the total we will get 8 possible values in this particular event. So what is the probability distribution? Probability distribution means when we distribute the possible values in the form of probability, that is called a probability distribution. Let's understand. Our sample space is that this is your our sample space. Okay, this is your our sample space. This is your possible random variable. This is your random variable. This is called as a x. When the x is equal to 0, it means no any head. So what is the probability of getting no any head? Is only this 1 by total is 8. So 1 by 8. So what is the possible value? Only one head. We can check here. One head is 1, 2 and 3. 1, 2 and 1, 2 and I think one head in this 3. There are the 3 head. 3 by 8. So whenever we have 2 heads, 1, 2 and 3, let's 3 by 8. All the 3 head, this is only 1. So 1 by 8. So this way we get the probability of value x. Like 1 by 8, 3 by 8, 3 by 8 and 1 by 8. If we do some calculation here, 1 by 8, we can provide this. There are 0.125 possibilities or 0.125 probability we have corresponding to getting no head. So this type of the distribution, if we provide in the form of probability, that is called a discrete probability distribution. Now understand the continuous probability distribution. So what is the continuous probability distribution? When the random variable is in continuous in nature. So and if we distribute all the possible values in the form of probability. for a continuous random variable, that is called a continuous probability distribution. Let's understand by one example here. Let this is the height and this is your peoples. There are some people whose height is between 4.5 to 5 feet. How many peoples we have? 20. And there are some people whose height is 5.5 feet to 5.5, and those peoples are 30. 6 feet height, 5.5 to 6, we have 40 peoples. Then 6 to 6.5 we have 30 peoples. 6.5 to 7 we have 20 peoples. Okay, so this type of the data distribution we have. So if we want to plot this particular thing here, this is your height and this is your people's count. So how we can height? This is your 4, this is your 4.5, this is your 5.5, this is your 6.5, this is your 7. So between 4.5 to 5 we have total, this is your 10, this is your 20, this is your 30, this is your 40. So between 4.5 to 5 we have 20. It means this is your 20. Now 5 to 5.5 we have 30. 5.5 to 6 we have 40. 6 to 6.5 we have 30, and from this we have 20. So this type of the distribution we have. So this is your histogram. So we need to convert this histogram in some functions like probability density function. Let's convert this particular in graph like this. So we can get like the graph is like you're showing this type of the data. So this particular graph, whenever we use this type of the graph, we need to we need to convert this y-axis is a function of fx, and this function is fx is called as a probability density function. We will discuss in separate video what is the probability density function. So what we need to remove these things here, or we can draw some another graph here like this type of the graph. We can do another graph here like this graph. Okay, and this is called as your f of x, and this is your height. So this is your middle value is almost between 5.5 to 6, then 6.5, then 7, then 5, then 4.5. So this type of the distribution we have. So this is your height. So in a continuous probability distribution, if I will ask you what is the probability of getting exact 5 feet height, so let's understand. If I will draw this 5, this particular value, and this value let's say is coming 0.5 probability, so you will say that the probability of getting exact 5 feet height is 0.5 probability, but this is not a case here. There are the 100 people in a class, okay, and if I will ask you to measure the height of all the 100 peoples and tell me what is the probability of getting exact 5 feet height, would you able to provide me the answer? I think no, because you cannot measure the exact 5 feet height. Exact means exact value of 5 feet, not it is 4.999, not it is 5.001. So we need exact 5 feet height. So it's likely to be equal to 0 probability. It means if anybody asks you what is the probability of getting 5 feet height in this particular distribution, so you will say that the probability is almost equal to 0, because we cannot measure the height exact 5 feet. So this is in a random in nature, because we cannot measure the exact, as we had used in discrete, that like the exact value of getting 1 or 2 or 3, but here we cannot use the exact value. We can use some this particular thing, like we can provide the probability of getting like between 4.9 to 5.1 feet height. We can provide the height between these two particular value, like what is the probability of getting height between 4.9 to 5.1. we can calculate by using this particular way, like let this is your 4.9, so we can use this particular thing like this. We can use this particular area, we can calculate this particular area, and by using that particular area we can provide the probability of this particular by using this particular function fx. So we will discuss how to calculate this probability by using this particular function, that is the part of the probability density function. This way we can distribute the probability of a continuous random variable.